Okay, today I'm going to try to design a 3-channel power amplifier for some of my other projects that I'm working on. So I built and designed this amplifier here, and it works pretty good. And I talk about this in a few of my videos, and then I make a amplifier based on this for my sound blaster device using Zif connectors, and I used a evil mad scientist I don't know, pick processor Zif kit to do that. And so I ordered, actually these are Zif connectors I ordered off of Amazon. Looks like the pin got bent there. And they're really nice because you can take your transistor or whatever device. They're not really made for transistors, they're made for ICs, but I wanted an easy way to change out transistors because they blow sometimes when I'm doing high power projects. And so you can stick them in there, and then you just pull this little lever down and it holds them in place, and then if you need to replace them, you can just pop this lever back up like so. So you pop it back up, and then the FETs come out easily, so you can easily replace them. And same is true with the Fet drivers. Initially I tried to put the Fet drivers and the FET in the same socket, and it didn't work out so well. But these things seem to stay sturdy inside of these normal, what do you call them? Sockets, dip sockets. And so I got some circuit boards, and I guess let's just see if we can lay out the circuit and see if we can get it to fit onto one of these boards. And these are from Adafruit, but probably could use other circuits. And we'll try to recreate this circuit here on this board 3 times. And what I wanted to mention is that these actually have 2 Fet drivers on them. These are the the 4424. I'll put descriptions of the parts in the descriptions. I believe these are the 640 IRF 640 FETs. So we need 3 FETs for the power output, but one of these can drive 2 FETs, and then one will drive another FET. So I can save on one of these Fet drivers by putting 3 of them on the same circuit. Okay, so here's the Adafruit. It says Perma Proto 1/2 size board, and it's got all the traces going out, so you can hook things out like this. And looks like it has a set of traces running this way and that way, so you can put power along the outside to anything you want. And so that's probably what I'll do. And on this other circuit I have a capacitor to help provide peak power to our Fet drivers. And there may not be a lot of room on center line after I start putting all these sockets. The sockets have to be on center line. So I'll have to probably put the capacitor off center, which is fine since the power lines are off center. Okay, I think it should work out pretty good. Okay, maybe I'll put 2 capacitors on it. Maybe I'll put 2 power lines on each side. I'll have to see how the layout goes. Okay. I'll probably take these Zif connectors. I want to put the lever so they go out like that. Let me just see if I can fit these on the board in a reasonable manner. Okay, so it looks like I can fit these Zif connectors, so they have all the pins on them and they hang off with the switch on the ends. And I can put the Fet drivers right near them, and I think that should give plenty of room. Remember, these FETs are going to need room for heat sinks, and you should be able to put two of these Fets back to back on one of them, like so. And then they should have plenty of room for heat sinks up here, so they won't interfere with each other. See that? Be able to put heat sinks here and over here, like so, and they should be able to be kind of have enough room for whatever kind of heat sink you want to stick on it almost. Okay. So I think this might be a pretty good design right here. So maybe we'll try to solder some of these things down and start preparing this board. Let's see, these Fet drivers will be able to fit in right in here, so you should have good access to them. And so it'll be like what, 1, 2, 3, 4, 5 main components. And if you need to replace any of these, it should be fairly easy. Okay, I'm not sure if you can see these pins very well, but the pins are here, and here, and here, and here. I have the board upside down, and I flipped out these levers so that it will lay flat. And I'm just going to solder probably the first 3. I'm not going to solder all these pins on. So let's just go ahead and put solder in here. See if we can. Ow. See if we can do this with 2 hands. Not Zaphoid Beeblebroth, right? Or however you say his name. So I gotta just be more talented. Okay, anyway, so I'll try to solder 3 on this side and 3 on that side. And then we should be able to fit the other sockets in and solder them in place and see how this goes. Okay, so I got my solder joints down. Let's take a look at it under the magnifying glass. You should always check your solder joints. Maybe I'll reflow these. See, I got 3 there, 3 there, 3 there, 3 there. These ones look like they need to be reflowed a little bit more. Okay, so maybe I'll do that. Touch them up a little bit. There. Okay. There, now I think all the solder joints look pretty good. Okay. Move on to the next. Okay, so here's our 2 Zif connectors soldered in place. I guess I can flip these levers back up so the springs aren't under compression. And let's see, here's our sockets. I think we'll fit one there, and we'll fit one there. It looks like there's enough room for 2 rows in between of stuff. I always like to have a little bit of extra room just in case things get too cramped or something. It starts to get a problem, you know, if you can't get parts in or whatever, or get wires in to cramped places. Okay, so just let me go ahead and I'll solder these, and these are going to be a little bit more difficult to solder in place since they're going to fall out if I'm not careful. Maybe if I use this heatsink as a table, it'll work better. Okay. Okay, I guess I had to flip these levers back out in order to really solder this. And that heatsink seems to work pretty good as a table. So here's our 8 pins up here. Let's see if I can do the impossible again. Okay. So let's go ahead and I'll solder all these 8 pins because I think we're going to use most of them, and I don't want to guess which ones I do and don't. Okay. We'll get those soldered up and then move on to the next step. Okay, again, let's check it under the magnifying glass and make sure our solder joints look good. And here's our new ones right here. I think they all look like they flowed pretty good. Okay. And there is our sockets. All of our sockets are in place. And I think we'll just have to start routing wires and have to get some capacitor. I need to get some capacitors. And I'm going to have to put some damping resistors, as I showed in my FET damping video, so that the FET doesn't ring when it's switching fast. Okay, and then we should be almost done. Okay, so the FET driver that we're using is a TC4424AV, and so let's see, let's look up the spec sheet on that and try to get this thing powered up properly, wired up. Okay. Okay, so here's the data sheet for the 4424 TC, or AV, I guess, TC4424 AV. And here's our dip circuit that we're going to be using. And it looks like pin 3 is the ground, and pin 6 is the VDD. And the top two pins have no connections, and then there's just through here, in and out on the 2 and 7, and in and out B on 4 and 5. So I think we're going to go ahead and get the ground and the VDD hooked up. And so if we look at our circuit here, we're going to have two of these. There's going to be a ground on this side and a VDD. And of course there's two power rails, one on each side, so I think I'll utilize both of them, hook them together, and then put a capacitor on each side. So we'll have a good peak power on no matter what rail you're coming off of. And let me get some wires measured out, and we'll get these fitted in place, then maybe solder them down. Okay. Okay. So I guess I changed my mind. Since this distance is really short, see these traces on the bottom go all the way out almost to the rails anyway. So I think I'm just going to use, rather than stripping back those other wires, I'll just use some snippets. Recycling, right? Recycling is always good, right? That's what the communists tell us. No, I like to be efficient, so I have these snippets, and I think I'll just bridge across these different gaps over here with these snippets of wire, you know, from the ends of resistors or whatever. Reuse them, and then I don't have to strip them. Okay, and that should be a quick fix for this. I'll get this wired up for the power. Okay. Okay, so here we are under the magnifying glass. Remember, the ground is the third pin down, and see, I have it jumpered to the blue rail across there, and the VDD is the third pin down from this side. That would be 1, 2, 3, 4, 5, so pin 3 and 6, and that one is jumpered to the positive. It's right across that gap there. And if we turn this around, of course we have to power this FET driver too. This one's going to have to go along across a larger gap, because remember, the VDD is the third pin down on the right hand side, and so that's going to go across to the second rail over here. And the same with the ground over here. It's got to go a little bit further distance on this side. But other than that, the circuit's pretty symmetrical so far. Okay. And so let me solder those in place, and we'll get the grounds taken, or the powers taken care of for the FET drivers. We'll move on to the next step. Okay, so anyway, let me get these jumpers soldered up here. Get my solder in place. There's one of them. Okay. So I did that one over there, and that one. And let's see, where's our other jumper? I guess it's right here. I'll get all four of these jumpers soldered up, and then we'll do the next step. Okay, so let's look at our jumpers under the magnifying glass. Here's one there, one there. I'll turn the board around. There's one there and one there, and I think all the solder joints look good. There's our jumpers. Here, here, there, and there. And so that will supply the power to our Fet drivers. And I guess we'll go on to the next step. Okay, so let's see, we got our dip sockets for the Fet drivers on there, and our Zif sockets. And I think I changed my mind. I think I'm going to go ahead and make this wired up so I can put 4 Fets in here. Why not? I mean, I have a couple projects where I only plan to use 3, but you never know. It wouldn't hurt to. It's just going to take a little bit of few seconds extra worth of work to make it so it can do 4. So we'll have a quad Fet driver, and there's uses for that too. Maybe with a transformer you could use it to make a full H-bridge power supply. Anyway, as I showed in my other videos, and even in this Fet driver and the other one I used for the sonic blaster, it's not here right now though, but you want to damp the Fets. And I was looking around, I just wanted to find some Fets see, these were about 2.5K that I used over here and on the sonic blaster. And this is all I could find in high power carbon resistors. You don't want wire wound because that will add inductance and you lose your bandwidth then. But hopefully this is enough resistance. This is twice the amount, so it won't damp it as much. But it's in the ballpark. So maybe I will try to position some of these resistors on here. Remember, it's going to be between the gate and the drain, which is, if we look at the Fet here, it goes gate, drain is the center one, and source. So it's between the left one and the center one. Okay. And of course the Fets are going to be in different positions as you stick them on here. I want to have it so the heat sinks face out like so. So on this one, the gate is going to be over here, and then the drain is going to be the next one over. And then when the Fet is in this position over here, the gate is going to be here, and then the drain is there. So it'll be between the first and the second here, and the second and the third on the other side. Okay. You remember, you can't. They're going to interfere with each other if the Fets are facing like that, and the heat sinks are not going to be able to, be compatible. So we'll just let me get some of these resistors out and see if we can fit them on this board. It may be a challenge. I kind of want to keep them low. On the other one, I stood them up straight, but I guess I might be able to do that depending on what kind of heat sink I'm using if I keep it out. But but anyway, I guess maybe I could stand them up straight and put them out toward the edge of the board, because my heat sinks that I'm planning to use are going to be similar to this, and so they may not interfere if I do it that way. So I don't know how else I can put these big ass resistors onto this circuit board and make everything so it doesn't interfere. I guess I just won't use a heat sink that has lots of junk in this area here. Like I had some that have fins that come out and pretty much fill this area. So that would not be a good choice if I'm going to use a big ass resistor standing straight up out toward the edge of the board here. Okay. Okay, so I think the next step that I'm going to do is put in the input wires into the Fet drivers. And here I strip back some wires, and if we look at our spec sheet here, the inputs are on pin number 2 and 4, so they're on either side of the ground, and the outputs are on the opposite side. So basically on the left hand side are the inputs and the right hand side are the outputs. Okay, so if we look here, the inputs will be here and here, and then if we flip it over, the inputs will be here and here. So let me go ahead and get that wired up and solder that up, and we'll move on to the next step. Okay, and here's my solder cam, and okay, there we go. Just solder these leads on the back, and then I'll clip them back a little bit once I'm done. Get all 4 of them here. Okay, so there we go. There's a certain kind of symmetry to the circuit. There we got the input wires hooked up. Okay, and then let me see, probably the next thing would be to hook the output wires from the Fet driver outputs to the respective Fets, and I'll have to figure out how I'm going to route those. Okay, so I think the next easiest route would be, this is going to be the output of B, right, from here. And I'm going to put a Fet, let me just put one in there, like so. So I can run a short wire, I've already got it stripped up, from the output of B right here to the gate, which is going to be the furthest pin on the right hand side, looking at the Fet right here. So this is gate, drain, source, going like that. So it'll just be a very short lead from, I guess, on my board it'll be row number 11 to row number, what is that, maybe, probably 7, because there's 7 pins in the Zif. Okay, and I'll check that to make sure. And then of course this side will be symmetrical for that particular output, and then I'll have to figure out how to wire the other ones. We'll do that next. So let me get these wires into here. Okay, so I have the outputs of the B wired up, and I just need to solder them. See, it's got a short wire from, what would that be, 1, 2, 3, 4, 5, pin 5 on the Fet driver to basically the 7th slot up. Okay, and let's just go ahead and solder these guys in place. Okay, and I'll just go ahead and solder all these in, and we'll go on to the next step. Okay. Okay, so here again is the data sheet for our transistor. What happened to it? Come on. Okay. So here again is our data sheet for our transistor, RL640. And it's a Fet. And here we go. Gate, drain, source. Okay. So here's our transistor. And so the gate is on the left-hand side when you're looking at the face of it. So when we put this one in the socket on this side, it's going to be the 3rd pin from the front, 1, 2, 3, and so let me see. I was making some wires that will kind of wind around from the output of A2. Well, let me get this in. Okay, it's easier to see under the magnifying glass. So this is the input here for the A channel of the Fet driver, and so we're going to take the output of that and wind it around to the 1, 2, the 3rd pin back where our other Fet's going to go. And we'll do that for the other side too, because why not? It's going to not take that much more effort to wire up a 4-channel amplifier. And then I'll solder these in place. Okay. Okay, so there we go. We have our two wires hooked up from the A outputs. This one wraps around and goes to the 1, 2, 3, 4, 5th pin from that side, which is going to be the gate, and also this one also wraps around from here and goes over here. Let's solder them into place, and we'll move on to the next step. Okay, so if we look at this amplifier circuit, the drain is the output of our FET amplifier, and that's what's hooked to our output load, and that is the center pin. So basically, where the center pins are going to be on these guys is going to be where the output is. And I strip back 4 of these wires, and I'll get them in place, and we'll solder those into the 4 different places where our FETs are going to be. Okay. So the source goes back to the ground, and so I'll do that after this. Okay. So we'll do the outputs of the drains, which are all the center pins. Okay, so the reason why I put the input to the gate and the output drain close in here is because I want to reserve these outer holes for our damping damping resistors. But I guess for the source, I don't need to worry about that. I'm not going to put any damping resistors between the source and anything else. So I think I'll just use these short little jumper, just pieces of wire that were left over, to jumper from the source to ground, the blue, on both sides. Okay, and that'll make it simple. So let me get those jumpers in place, and then we'll solder them in. Okay, so I have the jumpers in place. So on this side is gate, drain, source is on row number 7, and again on this side, gate, drain, source is on row number 26, and then it's going the opposite way on this side because the FETs are facing a different direction. So it's gate, drain, and then source is on 24, so it's jumpered to the blue, and it goes closer on this side since the blue is closer to the inner on this side, and it's a little bit further on the top because the blue is further away. And again, gate, drain, source, where this one's on row number 5 now, jumper to the ground. Let me solder those in place, and our circuit will be almost complete then. Okay, so the next thing I want to do, see we have these 2 power rails, one on each side. I want to be able to just power them with a single set of leads coming to them, so I'm going to hook the blue one with the negative to the negative on the top, and the positive on the bottom to the positive on the top, using some jumper leads, and solder them in place. Okay, and that will take care of our power needs here. Okay, and I guess so it doesn't get so crowded with so many wires coming close, I don't want them to short out. I'll do the blue on one side and the red on the other side. Okay, like so. And there's our power leads, and let me solder them in place. And I think we're getting close to finishing this guy. Okay, so the next step is I'm going to start putting damping resistors on the gate to drain, and on my other designs I used about 2.5K. These are labeled as 2.7, and here actually measuring it on this guy it says 2.5, so that's within the ballpark, so they should work just as well as well, I know this design works, so why not stick with it, right? Okay, so let's get them in place. I'm probably going to stand them up, and then the heat sinks will hopefully go around them, so we'll test that. Okay, so if I had more room, I definitely prefer to have the resistors lying down, but when you don't have a lot of room, you can stand the resistors up, and you can bend one of the leads around like this, and hopefully they're both long enough, and then you can minimize your footprint on the board. And I'm going to try to put them so that the resistor is centered over the drain to keep it in the center of the transistor. And then let me see if I can get this other wire down. Let me have to put it on the camera. the other wire right next to it. See if we can fit everything in there. Okay. And there we go. And it actually sits quite a bit lower than I thought it would. Let's borrow this transistor here and see how it's going to fit. Okay, so it looks like it's not really going to interfere. Nothing like building a whole circuit and then finding out it doesn't mechanically work, right? Electrically works, but doesn't mechanically work, so I think we should be good to go, depending on, yeah, as long as we don't use heat sinks that have fins in the middle. Okay. Anyway. Okay, so I'm going to suspect that these are probably about 2 ohms, or 2 watts, I'm sorry. They're at 2.5 kOhms. And I got them all in place. They're going to have to be able to handle a lot of power because they have considerable voltage across them. And for this project, I don't know, it could be 30 volts or more. And so there we go. I got them all in place. I guess I'll solder them on now, and then I'll start clipping off the leads because I think our circuit will be just about done. Oh, wait, yeah, that's right. I got to put some capacitors on it afterwards. Okay? I think we're pretty close to being set. Okay. Now I'll just quickly solder these things on. And I think I'll start, well, I just need to do the capacitors for the power supply and maybe some leads coming up to it. And then we'll start trimming these things off. Okay. Ouch. Okay. Looks like they're all soldered in place. And I did test one, make sure the resistance across it was okay, because I think I globbed too much solder on it. And I'm going to trim these back, and I think, let's see, I'll put some leads on it next. See if I can find some appropriate colored wires. Okay, so here's some red and black leads, and I think I'll just probably do red from one side, maybe this side over here, and black from the other, and I'll solder those on, and we'll be almost done. Okay, so I have the red lead hooked to the red power line and the blue, or the black one hooked to the negative, the blue one down here. And I think the last step is to put these capacitors on. I want to put one capacitor on each rail. So each rail will be supplying power. You want to have low inductance so you can get high switching speeds. And let's see if we can just fit these capacitors on there. Let's take a look at them. So these are electrolytic capacitors, of course, which means that you can't hook them up backwards or they will blow up. So be careful, take note. This is a minus and the other side is a plus, and they're okay, I guess they're rated for 25 volts. Okay, which is less than we're going to stick on the main circuit. We could put higher power on the FETs, but okay, just keep that in mind. 25 volts at 33,000 or 3,300 microfarads, I guess. Okay, let's see if we can fit them on the board without obstructing anything else. Okay, and it looks like it fits pretty nicely here, about with two rows in between, black on the minus side and the other one on the plus side. And we can slide this guy down so he seems to sit in the middle, and I'll get the other guy on there as well. Okay, get some of these leads out of the way. Okay, plus here and minus there. Oh, minus, come on. Plus there and minus there. No, still not where I want it to go. I wanted to go over there. Okay, there. That's about the right spacing. Okay. Yeah, there we go. Look at that. And let's just make sure that our FETs are not interfering. The FET heat sinks, what have you. Not going to interfere with this. Okay, so I think it's looking pretty good. I think we're good to go. Okay. Excellent. Okay, so I just got through soldering these capacitors on, and I think it's time to trim the leads. And I guess when you can't find your dikes, which I like to use dikes, sometimes fingernail clippers will work good. And again, I got these fingernail clippers with my pair of tweezers that I got a while back. Where are they? My sparkly tweezers. Because that's how they come at the CVS for putting little surface mounts on. Anyway, so who cares if I chew up these things or not, right? Okay, let me go through and I'm going to give this thing I'm going to lawn mow these things off, and we'll take a look at the circuit when we're done. Okay, there we go. We finally finished. Let's take a look at our handiwork under the magnifying glass, and I always do recommend, these are so great, especially when you start getting old like me and you can't see so well anymore. Okay, looks like I missed one there. You don't want those to short out against something else, and that is horrible looking, but it was hard to actually solder these thick leads because they acted like a heat sink and they're drawing too much heat away from the soldering iron. I'm going to check it again with my voltmeter, make sure that I didn't create any solder bridges, make sure all the solder joints look good. Okay, and I guess things are looking good, and wow, it's pretty impressive, huh? Be finished very soon. Okay, again, I cannot overstate the importance of testing your circuit. I have it hooked up to the ground here, and there should be 4 grounds to the FETs, and make sure things aren't shorted out, make sure connections are good, right? 4 grounds to the FETs. And let me see, the power supply has 1 ground for the Fet driver and another ground right there for the Fet driver. And again, power rails have power here, and just make sure the resistors aren't shorted out, and check everything before you put the power on it, because you will be sorry if something's bad. It's going to burn something out then if you don't check it beforehand. Okay, so here we got some heat sinks and our transistors, and I guess let's I got some screws here. Let's just put the screw through the transistor. Let's take a heat sink like so, and put the nut on the back of it. Come on, oh gosh. And there we go, a transistor with a heatsink on it. Well, let me do up the rest and we'll stick them into our device here. Okay, so I got all the heat sinks on the transistors, and actually I think I'm going to put the Fet drivers in the sockets before I put the transistors in, because they're going to be kind of down below the heat sinks. It's going to be a pain to get them in if I don't put them in first, so let's do this. There's where they go in the socket, and probably gonna have to put the camera down to wiggle them into those. Remember, get the direction right. The knot should be pointing in on both of them. Okay, there. I got the 2 Fet drivers in place, and I guess I'll just start putting our FETs into the ZIF. Okay. There we go. 1, 2, 3, 4. Make sure you get it on the right socket, and then you can just flip down this lever. Let me kind of hold this in place while I flip the lever here. Okay, and I'll try to hold these in place while I flip the lever. And there, everything should be locked into place now. Okay, there's your quad Fet driver power supply. Okay. Very interesting, huh? We'll have to test this out next. Okay, so I have just one of the channels hooked up to some batteries here, and variable resistive load just to test the bandwidth, and have the input at what, 51 kilohertz from our scope, or from our signal generator at square wave, and it looks like we're putting out a nice signal. Let me, 1 millisecond, let's increase the it might be aliasing. Okay, there's our signal. Looks like it is working fine at 52 kilohertz. Let me increase the frequency and see what our bandwidth is. It's about 100 kilohertz. Okay. Let me go up to the next scale. And there's 100 kilohertz. Okay. There's 270. Okay, so I don't think it quite has the bandwidth that the other one has. What is this? 133 kilohertz. Okay. So that's probably about the usable bandwidth right there. It's really starting to let me just put this on a faster scale. See, the waveform's starting to get distorted already at that frequency. Okay. That's too bad. I really wanted to operate it around. I guess it does put out some power at 260 kilohertz. 260, 270 kilohertz, but it's really not switching very well at that frequency. Okay. That's 100 kilohertz. Okay, so it could be the load too. Actually, now I remember, if the load is not low enough impedance. Let me fiddle with this. Okay, yeah, it does depend on the load, because I decreased the load and now the signal output is higher. So the transistors really want to see some current flowing through them, I guess, in order to switch nicely. Okay, so we're at 270 right now, kilohertz. And the waveform is a little bit distorted, but we're still putting out a good amount of power at that frequency. Okay. And so this is 450 kilohertz, and the amplitude is dropped by about half. So we should be able to drive stuff at that speed, depending on what the impedance of your load is. If the impedance of the load is too high, I guess it doesn't switch on and off very nicely, which makes sense because there's no place for the current to flow. Okay. So anyway, there's our 4-channel circuit. It looks like it's working good, so I might make a second one because I have several experiments I want to do with multi-channel amplification with high-power electronic signals. And this is Dr. James, and thanks for watching.